This is the title, downloading the entire Steam catalog with GitHub Actions. Maybe I said something else when I entered the talk. But essentially, for people that don't know what Steam is, probably not that many of us, but Steam is a video game store for PC games, and it's the largest store. Users of Steam have large game libraries, often several hundreds of individual games. And then they also have a list of friends. However, there's actually no way in Steam to filter against your set of friends and the set of games that you both share to actually play games with each other. So, and then you might also think, well, maybe I want some filters against my games or against a shared set of games for like whether they're multiplayer or cooperative, or they are allowed to do this remote play feature. Or maybe you want to see which games are free or on sale or priced below some amount. Or maybe you want to just see like which games have achievements that could be unlocked. So you can imagine there's a bunch of different metadata of each game that you want to filter for among a shared set of games. And this is not supported inside Steam. However, Steam does have a public API where you can query for a list of games per user. And then you can also get a list of friends for each user. And each of those is a single API call, a request. To get metadata about games, you actually have to make individual requests for each game. So the data that comes back for your list of games is just the name, essentially. And then to get any information about the games, you have to make a bunch of several requests. So essentially, to be able to do this filtering that I'm talking about, aside from anything apart from just the name of the games, you need to essentially make hundreds of requests to the Steam API in order to populate this list or to be able to do this filtering. And then the final sort of problem here is that the Steam API has extremely aggressive rate limiting, unless you're like a developer, a game developer, which I'm not. And I think that may either cost money or you have to register for or something. So the rate limiting is like 1 request per second. So you can imagine if somebody wants to do like log in, they want to view these shared set of games, they're going to be waiting a long time for that list to populate. So, so what's the solution? So the solution is something called the baked data paradigm. At least this is my solution. So I didn't come up with the baked data paradigm. This is something that Simon Willison came up with. And he's got a blog post. It's really awesome. It's linked here. This link will take you to it, or you can just go to Simon Willison's blog and search for baked data. Essentially, the term is, the paradigm is that you bundle a read-only copy of your data alongside your application, like as you're doing a deployment. And so he also has an actual application that makes use of this paradigm called Dataset. What Dataset does is it allows you to make arbitrary SQL queries against a bundled SQLite, I sometimes say SQLite or SQLite database that's actually embedded inside the deployment of Dataset. And then it presents those queries as HTTP endpoints. So you could basically make a SQL query against your database, and then the SQL query is actually represented in the query params in the URL. And so you can actually pass that along to somebody else if you wanted to. It makes for easy sharing, but also allows you to basically formulate a SQL query that will be an endpoint, such as like, I want to query for these columns in the database about like the type of data or something, like the type of game, I mean, like whether it's multiplayer or something, and have that represented as an HTTP endpoint. So, so essentially now we just left for the final problem is we need an SQLite database of the entire Steam catalog. And so what I did is I programmed a scheduled job in GitHub Actions to make slow queries against the Steam API for every single game. And it actually runs repeatedly and updates the metadata continuously. So this database is always up to date. And then inside the job, we save the metadata that comes out into a SQLite database file, which then gets published onto a dataset deployment. And I'm using SQL Model, which is a very nice library written by the same person that made Fast API, and it basically joins SQL Alchemy and Pydantic together in a very nice, elegant way. And so by creating this job that can run over days unattended, we can make requests slowly. We avoid getting rate limited. We can have multiple retries. And right, so basically, we now can take this dataset API and give it to a front-end application to make requests for and generate the actual application that users will end up using. And this steam-2-sqlite.vercel.app is where it's hosting. You can visit that now if you want, and you can play around with this data. It goes all the way back in time to the very first published Steam app, and do all sorts of crazy queries. And this is basically just looking at the number of games registered on Steam over time. And you can see, I ran this query, I think yesterday. As you can see, the number of games is exponentially increasing here. Maybe there's a little plateau, or maybe this is just not good data here for the last year. And so, yeah, so that's basically it. This is the repository that I have to run these jobs, the workflow file, and generate the SQLite database. You can download the SQLite file directly from this link. And then the actual deployment of dataset is done to Vercel at this URL. And then the application, which is shown on the right here, was written by my friend. And it was written in Elm. It's not written by me at all. We worked together on this, but you can actually try that out as well. That's at team-party-join.lambdera.app. And the code for that is located at this Bitbucket URL. Yeah, that's it.